Okay, in this problem, we have an electrostatics problem, and we've got four charges. The charge here is a positive 2 microcoulomb, and we've got a distance like this and a distance like this. This distance is 50 centimeters. This distance is 50 centimeters. And right here, we've got another charge of -3 microcoulombs. Here we have a charge of -3 microcoulombs. And right here in the middle, we have a charge of +1 microcoulombs. Now, this one is right in the middle, so it bisects the two. This angle here is 90 degrees. Therefore, this is 45, and this is 45. The question is, what is the force on the 2 microcoulomb charge? So find force on +2 microcoulomb. Now, in order to do this, let's change colors. We're going to notice that there is going to be a force of attraction because this is positive and this is negative. So there is going to be attraction here. There's also going to be an equal amount of attraction force here. And you notice the symmetry. Okay, so the distances and the angles and the charges. Now what that symmetry tells you now is that these two forces are going to add like this. To create a horizontal resultant to the right. Okay? How much is that? Well, this angle is, as we said before, 45. This angle is 45. Therefore, this angle is 90. And all we need to do to figure out this is use KQQ over R squared. So if we use the force F equals KQ. Now, I don't have letters here, but I could use them. So let's call this one A, B, C, and D. So force on A due to B is QA, QB all over RAB squared. Now that's going to equal 9 times 10 to the power of 9. That's the constant K. I'm just going to leave off the units for now to keep things simpler. And Q, A being 2 times 10 to the power of -6 coulombs. And B being 3 times 10 to the power of -6. Divided by a distance of 0.5 meters squared. Now that's going to give me 9 EE9, enter 2 EE6 negative times 3 EE6 negative times 0.5 squared divided by. And that gives me an answer of 0.216 newtons. Now, that means this is 0.216. Therefore, this is also going to be 0.216 because of symmetry. And therefore, this guy is going to be using Pythagoras, 0.216 squared plus 0.216 squared, take the square root of that, or basically 2 times 0.216 squared. So let's square that. Square it, and then 2 times, and then take the square root, and I'm going to get an answer of, that's equal to 0.3055. And of course, therefore that is here, right? 0.3055. And that's to the right. Now, the only one left that we have to worry about in this case is the 1. This guy actually repels the positive 2 to the left. So in fact, we can now substitute, or not substitute, subtract that guy. So let's find force on 2, sorry, not 2. Let me write that again. The force on A due to D, that's K QA QD all over R AD. Now, squared. What's that going to equal? 9 times 10 to the power of 9 times QA, which is 2 times 10 to the power of negative 6 coulombs, times 1 times 10 to the power of negative 6, divided by, now what is this distance here from here to here? Well, the way we're going to figure that out is we're going to say if this is 50 and that's 45, this distance is 50 cosine 45. So we can just say it 0.5 cosine 45 squared. And that's going to give us, let's try it, 9 EE9, enter, 2 EE6 negative times 1 EE6 negative times 0.5, enter, 45 cosine times squared divided by. And that gives us an answer of 0.144. 0. And now this now is to the left. But if you remember, this was the 0.3 was to the right. So we have 0.144 to the left, and we also have 0.3055 to the right. Now if we subtract those, we will get 0.3055 plus an answer of 0.1615. So our final answer is to the right 0.1615 newtons to the right, and that is our final answer. Basically, we got that by subtracting the 2. And I know that this guy's bigger, so the answer is to the right that much. Well, that's what these 3 forces, 1, 2, 3, are going to impose onto the positive 2 microcoulomb charge. Hope you enjoyed this problem. That's the end. Thanks for watching.